Türkiye döküm sektörünün değerli temsilcileri, yeni yılınız kutlu olsun. Yeni yılın ikinci webinarındayız. Biz hızlı yol alıyoruz. Geçen hafta bildiri yazılımı konusunda Profesör Doktor Özgün Kereş bize bir sunum yaptı. Niye bunu öncelikle yaptık? Gerekçesi de Ekim ayında İstanbul'da düzenlenecek olan Dünya Döküm Kongresi 76. Bununla ilgili etkinlikleri eminim izliyorsunuzdur. TÜDOKSAT haberlerinden, hatta 76 VFC sitesine girdiğinizde orada tüm detaylar var. Bu hayli önemli bir etkinlik olduğu için onunla ilgili bildiri yazım eğitimini öne aldık. Şimdi onu geçtikten sonra bugün FOSECO'dan reçine sistemleri ya da ekranda gördüğünüz gibi Alkali Fenolik reçine sistemlerine ve kum reklamasyonu için temel süreç performanslarına pratik yaklaşım konulu bir sunum izleyeceğiz. Sunum İngilizce hazırlanmıştı ama FOSECO Türkiye ekibi bunu Türkçe'ye çevirdiler. Bu ortak kararımız. Ekranda Türkçe göreceksiniz. Sunum İngilizce olacak. Zaten webinar duyuru metninde de bunu dinlemiştiniz. Şimdi bundan sonra ne var? Bundan sonra bizim bir sonraki webinarımız 20 Ocak'ta. 20 Ocak'ta değişim ve değişimin kurumlarda yönetimi başlığıyla bir başka konuyu ele alacağız. 2025 ne kadar yoğun geçmişse TÜDOKSAT Akademi faaliyetleri açısından bu yılda gene her ay 2 minimum, bazen 3 webinarla karşınızda olacağız. Şimdi hızlıca tekrar hatırlatacağım. İlk defa webinarlarımıza katılanlar için aşağıda sohbet kutucuğu var. Sohbet kutucuğuna sorularınızı yazmanızı bekliyoruz. Bunlar İngilizce olabilir, Türkçe olabilir. Şu anda tıkladığınızda zaten 76. Dünya Döküm Kongresi'nin web sitesinin adresini görüyorsunuz. Oraya girdiğinizde. Sohbet kutucuğuna yazmanın ötesinde sunumun sonunda bir memnuniyet anketimiz var. Bunu mutlaka cevaplandırmanızı istiyoruz. Bu bize genel fikir veriyor yaptıklarımızın ne derece doğru olduğu konusunda. Şimdi kısaca bunlardan bahsettikten sonra ben kendisini tanıtması için sözü Sayın Konuşmacıya vereceğim. Yes, Mr. Schrey, you are from FOSECO, and I will ask you to introduce yourself first and then start your presentation, please.
Okay, many thanks. Ladies and gentlemen, very good afternoon. My name is Alexander Schrey. I'm the Global Product Manager for Binders. And many thanks for having been invited by your commission and your committee. We would like to discuss today about Alkali Fenolik ester set binders. I'm, as said, the Global Product Manager for Binders. I'm working for FOSECO since 21 years. From education, I'm a foundry engineer working in the area of binders, resins, and sands since almost 36 years. So I'm going to present, unfortunately, just in English, as my Turkish is not that fluent. However, as you may see, the presentation is, thanks to my dear colleagues, has been translated into Turkish language, which might ease the follow of the entire content. Please feel free to ask any questions in that respect, either in Turkish or in English. In case you do it in Turkish, my dear colleagues will translate, and we will hopefully provide you with proper answers. Okay, thanks again for your attention, and I'm now going to start. Well, what are we talking about today? Alkaline phenolic binders, in particular those which are ester set. So we will cover the main binder components, which are involved. Don't be afraid. I'm not doing any chemical lesson, not at all, but just introducing briefly the main binder components. From a foundryman's perspective, I think it's significantly more important to know something about the scent requirements. And of course, excuse me, this is the practical approach. We are talking about product application and typical scent control parameters, which everyone who is dealing with this type of binders should be aware of. We will spend some time on what we call scent management. So what is important for you and us being partnering here to control in respect to the scent management, including the important topic of scent reclamation. And finally, we will just sum up and go back to the main topics of this session. So, basically, alkaline phenolic binders, irrespective where they come from, where they are made, they are from chemistry, always based on the same setup of main components. So basically, we are talking about a two-part system comprising of a phenol formaldehyde resin and the esters as part two components, sometimes called catalysts. In that respect, that phrasing would not be correct. It's even more than a catalyst. It's a co-reactant which undergoes a chemical reaction with the resin. The resin, as said, does contain phenol and formaldehyde. That's basic organic material. However, in contrast to many other binder systems you may be aware of, for example, cold box binders, these ester set alkaline phenolics are water-based systems. They are highly alkaline due to the presence of alkali metals, which play a significant role. And as any phenol formaldehyde resins, these alkaline phenolic binders do contain various additives to ensure proper pattern release, for example, to ensure significant bench life, and also to ensure that the binder has a good adherence on the scent grains. Part two, as said, is always, in any case, an ester, a single ester, or even a mixture of various esters. These esters are selected from various raw materials and composed to the final product in order to provide you with the required setting properties. So, scent requirements. I'm aware of that. There are probably many foundrymen from foundries who are casting basically steel castings. They may not in every event use silica sand. However, silica sand is the most common sand material for alkaline phenolic binders. Anyhow, as you will see later on, other sands than silica, like olivine or chrome sand, are also applicable for these alkaline phenolic binders. There are not that much requirements in respect to silica sand, again, compared to cold box binders. So the binder system, alkaline phenolic, is less demanding That means, for example, the acid demand value is not as critical as it would be for cold box binders. Anyhow, we should aim for a high SCO2, silica sand or silica content. The simple equation is the higher the better. We recommend not to use any sand with less than 95% of SCO2. Even more important, and this is in particular true in context of sand reclamation, which we will touch later on, is that the sand should be free of fines. So what does free mean and what does fines mean? We at FOSECO defined fines as particles smaller than 20 micrometer. This is also known as clay wash content in terms of measurement. And this amount of fine particles should be, again, as low as possible. Following our recommendation, we think if you aim to get these fine particles at a level of less than 0.5%, that would be really good in order to save binder and in order to prevent also from casting defects. We also recommend to monitor, to control the sand distribution. This is in particular true if you are going to reclaim the sand, either just mechanically or maybe mechanically and thermally. In case the reclamation settings, so both the sand attrition and the sand dedusting, are not adjusted properly, you may either end up with an excess of fine particles or with a significant change in the grain size distribution. So the aim, or the simple rule of thumb, is that ideally the sand distribution of a good, properly reclaimed sand should not differ significantly from the new sand composition. Okay, let's now talk about some key parameters of product application. So sand mixing. Again, we are talking now, I know that, being a foundry man, probably from a just theoretical standpoint, and in particular when we are here with experts, together with experts from Turkey, who are used to have significantly higher sand and binder temperatures and ambient temperatures. But from the chemical standpoint, it would be ideal to keep both sand and binder around 20 degrees. This is just due to the chemical composition and the reactivity of the binder system, which works perfectly at an optimum at 20 degrees. Is this written in stone? No, not at all. Not at all. So we are also used to sand systems which have to work in significantly hotter climates. So we are also used to work with alkaline phenolic binders at ambient and sand temperatures above 40 degrees. But this does certainly require a very good sand control, and that's what we have to state clearly, far away from being the optimum. So the closer you come to that level of 20 degrees, the better. But as said, alkaline phenolic binders will work by good sand management, proper selection of binders and esters, also at higher temperatures, as well as they work on at lower temperatures in wintertime, even down to 5 degrees. The usual order of addition is, again, also pretty simple. Once you have your sand, either new sand or reclaimed sand, you will first of all add the ester component, and followed by the resin. This is the usual and highly recommended sequence of order, due to the fact that we have to achieve the best optimum homogenization of both binder components. And this is about to happen if we add the very low viscous ester beforehand, before we add the more viscous phenolic formaldehyde binder. What you see is I put it in brackets on the left-hand side. Sometimes we even add, prior to the ester, we add some water. So what does it mean? Why should we add water? And when should we add water? Well, the addition of water is something special, which we experienced already many years ago. And I have to say in advance, this is not true for any binder system and not true for any sand system, but we should check whether or not the additional addition of water will improve the overall performance. In general, the addition of water is or can be necessary only if you are using reclaimed sand, as reclaimed sand does contain residual alkaline components from the beforehand binder addition. We know that these alkaline residuals in reclaimed sand are highly hygroscopic, and they have a tendency to absorb water from the resin. I mentioned already in the beginning that these binders do contain water. So why not take the water from the resin, as it is in aqueous solution? Well, the water content in the resin is properly selected and properly adjusted. So if we have to reactivate the residual alkaline, we have to do this by additional water. The levels are pretty low, as displayed on the left-hand side, just 0.2 up to 0.5%, might help to reactivate that residual alkaline components, which will then contribute to the overall performance. So this is something you should know, and we can check this in the lab pretty easily, whether this is essential for your individual binder system. But please keep in mind the addition of water might help to improve the overall performance. Sorry. So just a table with some data on very typical binder addition rates. I think the easy learning is that depending on the silica sand quality and performance, these addition rates might differ slightly, either higher or lower, but in average, we see that usually using a high quality alkaline phenolic binder, 1.3% of resin addition should be sufficient to achieve a good performance. If you are going to use reclaimed sand, the resin additions are slightly higher. We also displayed the typical binder addition rates for zircon, chromite, and olivine sand. And these addition rates do just differ due to the open structure of the individual sand grain surfaces, as well depending on the chemistry of these non-silica sands. What you see on the right-hand side is that irrespective of the selected sand, the ester addition rate is always the same, between 20 and 25, 20 and 22, up to 25 for reclaimed sand based on resin. So these are the typical addition rates of the ester. Okay, something we would highlight in that context as well. On the right-hand side, we state that you should never ever add more than 20 up to 25% ester based on resin. If you suffer from whatsoever insufficient binder performance, please ask your binder supplier to check, but do never ever add more binder, do never ever add more ester in order to obtain a better performance, as this will not happen. The ratio between binder and ester is constant, and in case you would just add more ester, you will not alter the performance. You will just increase costs and waste money. Second point in that context is, and this is significantly different to what you know from example from furan binders, is if we want to change the speed of reaction by keeping the type of binder, we always have to change the ester grade, but not the ester addition rate. So again, the simple statement is, irrespective of the selected ester grade, irrespective whether you require a very short set time, a medium or long set time, the ester addition rate will always stay the same. You just have to alter the type of ester. And again, if you are working in different climates, so you have to achieve certain set times in winter as well as in summer, this is possible easily, that can be easily achieved, again, by proper selection of the ester. And this is in practice no problem at all, as usually there are 20, 25 different grades of esters provided, and it's just about the selection of the optimum grade in order to achieve the best performance for your individual setup, which means for your binder system, which has been pre-selected for your sand and your ambient and sand temperature. Modern binder mixers and binder dosing units do offer usually the addition of just more than one grade of ester. But if you would like to spread the overall range of products to be made, so talking about small cores, small molds, up to bigger or larger molds, you may have to alter the ester, as said. This is usually no problem if you just follow one rule of thumb. So you can mix easily a fast and a medium ester to get any set time in between the set time of the fast ester and the medium ester. And you can also mix a medium ester of medium reactivity with a slow ester, slow setting ester, in order to achieve something in between. But you should never ever add and mix a fast and a slow ester, as this would definitely not work and result in poor through cure and also spotting of areas in your sand mold which are not cured properly. So what does it mean to mix fast and medium and slow? This has to be proposed by your binder supplier, and he has to provide you with the information which esters can be mixed easily in order to obtain the required setting properties. Something which is quite often overseen is what we call mixer control. So we strongly recommend to clean mixers at the end of every shift, and also to control these mixers in respect to blade wear and whether the injectors for resin and ester are still clean. It is also important that you check whether your mixer does have a couple of what we call hold back blades in order to prevent what is called resin spotting, which is an uneven distribution of binder. So in case you see some insufficient through cure in your mold, you spot that some areas are cured properly and others are not, you should always have a look at your mixer prior to checking the binder or the ester. So it's very common that this is overseen, and just by putting a lot of caution to your sand mixer, to the quality of cleaning, the operation and the maintenance will certainly help you to provide to get the optimum performance. Just displayed again from practice, on the left-hand side, you see a mixer that apparently has not been cleaned properly, and you can even see that on the left-hand side, which is displayed by the red arrow, some resin has been inked to that surface, and there's a relatively thick layer of cured sand. This can cause uneven and not equal binder distribution. You see it here on this picture in the middle. This is what we clearly call resin spotting, so uneven distribution. However, in practice, you will hardly see it if you are working with reclaimed sand. This is apparently new sand, where you can see as a result, once binder and ester have not been added properly due to poor mixer maintenance. And this, at the end, may cause in poor strength and cracks as displayed here. Well, type of mixers, that's pretty easy. I think the majority of mixers that are used are high-speed continuous mixers as displayed above. You can, however, also use batch mixers, but this is in practice not very common. And if you have to do so, just in order to make maybe a low number of cores in a different aggregate, you should definitely take into account that the intensity of this mixing is higher than in a batch mixer, in a continuous mixer, and therefore you probably have to go for a different type of ester in order to accommodate this. Okay. As said, our recommendation is to work around 20 degrees. And as we are not sitting in an ivory tower, but know from practice that this is difficult to achieve or even not possible to achieve in summertime, you are going probably for a modern blending system, which we can highly recommend. This is looking more or less like this. You have a mixer, and in your control cabinet, you do have next to the resin pump two pumps, two pump system for two different esters, and a learning PLC interface, which also takes into account the actual resin and, even more important, sand temperature. So systems like this are capable to adjust the addition rates and the composition of ester A and ester B, or ester 1 and ester 2, according to the required setting parameters, taking into account the sand temperature. This is highly recommended also in order to make the very best out of your binder and out of your ester system you are going to purchase. Okay, now let's go to the next chapter. Let's talk about sand control. Again, we recommend highly to provide at least a minimum setup for internal sand testing. Yes, your binder supplier can help you in that respect, and we as FOSECO do strongly believe it is something which is an important service element. But irrespective of this, you should be able to at least monitor a few key performance indicators of your sand system by your own. So in terms of those which are important from our point of view, we say, well, sieve analysis is definitely key to control both new sand quality and even more the quality of your reclaimed sand. Again, we say the grain size distribution should span over 3 or maybe also 4 sieve grades. This is sufficient for alkaline phenolic binder systems and the mold making process. As said already before, the level of fines, these small particles smaller than 20 micrometer, should be as low as possible and definitely not exceed 0.5%. The world is not about to collapse if you have 0.6, but 0.7. Sand is, as we know, not constant. But if you see development that the level of fines is going to increase, you have to counteract and try to minimize this, usually by controlling your reclamation system or your dust extraction system. And in order to achieve good, consistent sand quality, you should also monitor that the AFS value from your reclaimed sand does not differ significantly from the given data which is displayed in your new sand certificate. Loss on ignition is a very simple method in order to control also a key sand parameter. Basically, the loss on ignition measures the organic matter of your binder system. So the organic matter means the phenol formaldehyde binder, which is part of the binder component A, as well as the ester, which is also organic matter. These tests should be run at in a kind of muffle oven for 3 hours at 900 degrees. That's our recommendation. Then you are sure that all the organic matter has been burned off. So what are the values you are aiming for, you are looking for? We think if you are able to obtain about 2% of a loss on ignition as a maximum, you are on the safe side, and you should not experience any difficulties in respect to poor bench life or even gas defects. Again, if you are able to decrease this value thanks to a proper reclamation, that's even better. So anything between 1.5 and 2% loss on ignition is good. The next parameter is, we have to admit, pretty difficult to measure in the usual foundry man's or foundry lab. The elutable alkali content is something which determines the residual inorganic material. As we introduced in the beginning, your binder comprises of a phenol formaldehyde compound next to alkali metal. And these alkali metals, which are essential for the operation of this binder system, they stay as residual inorganic material on the sand. So even if you are burning the sand at 600, 700, 900 degrees, the inorganic material will stay on the reclaimed sand. Here we again can give some indication. We recommend a value of maximum 0.2, and again lower values around 0.15 or 10% of the LOI are indicating what is recommendable and what is good for your entire sand system. If you exceed these values, you will definitely end up in a lower refractoriness of the sand. You will reduce the bench life, and you will also reduce the molding strength. And due to a low refractoriness of the sand, due to high residual inorganic material, you will also probably face sand fusion and the formation of sand lumps. And this is certainly something which nobody wants to have. We acknowledge that it is, as you see on the left-hand side, this measurement of elutable alkali is a bit tricky, as it does require certain lab materials, a relatively simple lab equipment, but it's a titration process which has to be done by an experienced worker, and results are not easily available in short term. A good replacement from our point of view and an alternative to the measurement of the elutable alkali is to measure the electrical conductivity. And the measuring device is displayed on the left-hand side. And if you do so, you will end up in very short notice. So the entire measurement takes just a few minutes, including preparation of the sample. You will get some results which clearly indicate whether your sand does contain a lot, i.e. too much, or an appropriate level of alkaline compounds. This is something we can clearly recommend, and this is in particular a very good measure in order to control reclaimed sand. You may have heard about the pH value. So we mentioned in the beginning that these alkaline phenolic ester set binder systems are highly alkaline, so they have a very basic pH value, and maybe your sand lab is already measuring the pH value to control new sand quality. This is good, and this is something we can still recommend. But is measuring the pH value also something you should do when you control your alkaline phenolic binder system? Well, in fact, it is unfortunately not helpful at all. And what we have displayed here on that chart is relatively simple. As you see, we have just assessed 3 different sands, which we just call poor, moderate, and good in respect to the sand quality. And this is associated to the corresponding strength level we achieved. So a good sand here means we achieved, under certain conditions in the lab, a compression strength of 180 Newton per square centimeter, which is a good average value you will probably achieve with a sound binder system. If you measure the pH value of a sand like this, you end up with a value of around 10, maybe 9.5, 10, or 11. If you go for a sand which was perceived to perform pretty poor due to a high residual alkaline content and a high level of fines, you will immediately end up with poor strength. Even core and mold breakage may occur. And if you just measure the pH value of a sand which has a poor performance, you will see no significant difference to a good performing sand. So the simple learning of this is, forget about measuring pH in context of alkaline phenolic ester bonded sand. It does not give any meaningful indication or direction. All right, talking now about sand reclamation. What we would like to address is that apparently we know that both the binder and the new sand undergo audited quality processes before they enter any foundry. But if you just put it into that display as we did, you see both sand, new sand, and resin may make up 20% of the entire sand. The majority is reclaimed sand. And reclaimed sand is therefore quite often the unknown component, however, having a strong impact on the overall performance. So therefore, it's a necessity to control the reclaimed sand and to know where you are and what to do. Basically, reclaimed sands are used to lower process costs, as you do not need to go for new sand. And apparently you also overcome the problem of excessive waste sand disposal, which is usually also associated to costs. The reclamation process is basically just defined by removing residual binder by sand grain attrition, if you are talking about mechanical reclamation, or also thermal reclamation, which burns off the organic matter, as mentioned before. In that context, it is important to understand that there is no need for you to remove the entire binder from your reclaimed sand to be used again in the next cycle. This is not necessary at all, but you have to remove residual binder to a certain extent. And this is probably some of the key learnings which we would like to make you familiar with. And this is very important to understand and to put into the daily practice in order to balance out what is necessary to have a proper sand to be reduced, but not to spend too much energy and too much money at the end in sand reclamation. So, as said, the before mentioned sand control systems are definitely something we are recommending from FOSECO to monitor and to control your sand. And what we can offer as FOSECO is also to help you in that respect and to support you in order to get the best and consistent sand quality you have to have. So in that respect, what we already mentioned beforehand is you should never, ever compensate poor strengths, low strengths by increasing the binder content. If you already suffer from poor strengths, it is absolutely essential to identify the root cause for this. Just adding more binder will not heal the problem in no case. Some experiences is that we used to make critical molds or pretty complex cores in alkaline phenolic binder systems, usually with new sand. In order to process as much reclaimed sand as possible, in order to save new sand or to reduce new sand purchase, we recommend to use reclaimed sand always as backing sand, and also to use reclaimed sand in particular if you are using mold boxes. So again, not surprisingly, if you are working on boxless molds, you have to even monitor your sand quality to a much higher degree, as the strengths have to be higher for boxless molded molds. Well, what is the meaning of sand reclamation? So basically, it's about the reusage of sand after pouring. And by means of the reclamation process, old binder components, the residual binder has to be removed. In that respect, as said, we recommend to remove the binder largely, but not completely. It is, as said, not necessary to remove the binder completely in order to achieve a good sand performance and in order to achieve consistent sand quality. This is not necessary at all. And we are trying to make you familiar with this statement by using this display, this graph. As said, alkaline phenolic sand contains, once it has been used, residual organic binder and residual inorganic binder. In terms you apply a thermal reclamation, you are immediately removing the organic binder completely. So after a thermal reclamation, all the organic compounds are burned off, usually as water and CO2, and they are gone. The inorganic binder, however, stays. The residual inorganic binder stays. And even after thermal reclamation, there's a certain content of inorganic binder still on top of your sand grains. By means of a thermal additive and a proper dust extraction, you are able to remove the residual inorganic binder, i.e. the alkaline compounds, to an acceptable level. And we have run in our lab a simulation of a thermal reclamation. And this is just about to show you what is going to happen in practice. You do not see it in your foundry, but we have done tests in our laboratories, and the findings of these test sequence of this test program is now displayed in the next slides. So what we have done is we have taken new sand, added binder, applied a thermal load, and after that cooled down the sand and run a proper homogenization process, and then started testing. And this has been done 5 times. So we added 5 times binder, which has been burned, simulating a casting process, and then we have tested the sand we ended up. And what you see is the display of typical sand parameters, which have been already mentioned beforehand after these 5 cycles. You see on the left-hand side, we start with new silica sand, and the pH is apparently just driven by the pH of the new silica sand, which is about 7. LOI, there's almost no LOI, as new sand is free of organic matter. So once we have added binder in cycle 1, 2, 3, and so on, you see, not surprisingly, the level of organic matter of binder is going to increase step by step. And this is displayed by the loss on ignition line, which is displayed in green. And as before mentioned, the pH value does not matter at all. So even after adding just 1 set of binder in cycle 1, we already have a pH of 10, which does not change at all when adding even more binder. What is changing as well? Well, as mentioned before, the electrical conductivity is also changing incrementally, step by step, cycle by cycle, from 0 in the beginning. New sand has an electric conductivity close to 0, up to 700 microsiemens per centimeter after 5 cycles. And the ADV is, by the way, performing almost the same. ADV, again, the acid demand value, is requiring a titration process, and we do not recommend to measure ADV. Measure just electric conductivity. That's much easier to do and also very, very reliable. We have even more checked the true level of sodium and potassium in sand after any cycle, so after step 1, 2, and so on. And you see the level of inorganic matter is going to increase as expected, step by step. The next step of this testing program, excuse me, has been the reclamation phase. So the used sand, after 5 cycles, has been reclaimed thermally, and afterwards we cool down the sand, run a proper homogenization of the sand, and applied another set of sand testing. And the outcome is displayed on this slide. So used sand after 5 cycles has an LOI of almost 2%, as you see on the left-hand side. We have measured pH 10.5, electrical conductivity 686 microsiemens, and so on. Then we applied a thermal load of 600 degrees for 1 hour. And this is basically a simulation of what a thermal reclamation plant does in your foundry. And you see the LOI, the organic matter, is almost gone completely. So we end up virtually with no organic matter at all, as displayed by the LOI of 0.08%. As mentioned before, pH is apparently not helpful, not meaningful at all. pH has increased slightly, but it does not give us any indication what has happened. What you see already, the electrical conductivity has gone down to a bit more than 400 microsiemens, and the sodium and potassium level are almost the same. Then we have applied without adding, and this is also important to mention in that respect, without adding a thermal additive, which we'll come to at the next slides. However, without adding any thermal additive, just by pure dust extraction from the sand, we achieved already a significant reduction of the alkaline compounds. So we went down from 2.29 milligram per gram down to 1.66 for sodium, and from 2.5 down to 1.45 just by simple dust extraction. So the simple learning is just by removing these fines, which contains the residual alkaline contaminants, you already are coming closer to a good sand to be reused in your foundry. And this is, again, as we said, to measure the true alkalinity. So the sodium and potassium level is not that easy, but you see already by just measuring the electrical conductivity, you see a further significant reduction from 424 to 300 microsiemens. So this is probably, if you don't mind to say, this is probably the most important statement in context of sand reclamation for alkaline phenolic bonded sand. Proper dust extraction is absolutely necessary to achieve good sand quality. So reclamation phase, what you see with dust extraction and without dust extraction, you see, as mentioned before, a significant difference in electrical conductivity. And now we have added a thermal additive. And you see, irrespective whether you have dust extraction or not, the electrical conductivity is going down. However, you see a better sand quality, i.e. lower electrical conductivity is only achieved if you extract these fine contaminants of alkaline components by means of a proper dust extraction. And you can do this, or we have done this measurements also for the acid demand value, which follows the same concept and which follows the same principles. And we have even measured finally the true level of residual alkaline components, so sodium and potassium, again, based on different addition rates of a thermal additive, and again, with dust extraction and no dust extraction. So the learning is just by dust extraction, you are on the right path in order to improve sand quality. Secondly, this should be powered also by a thermal additive. and the application rate, the addition rate, is about 1.5% if you use a good thermal additive in order to achieve a good quality sand in combination with a proper dust extraction. How does the addition of a thermal additive look like? Basically, these thermal additives are products which are liquid. They contain a clay, and this clay has basically two tasks to fulfill. On one hand, yes, the clay undergoes a chemical reaction with the residual alkali, and this helps to reduce the alkaline content in your reclaimed sand. But secondly, and this is as important as this removal of alkaline, is to prevent the sand from forming lumps and to fuse. So basically, once this thermal additive is supplied to a foundry in a liquid as a liquid additive, we just blow air in order to homogenize this liquid and the clay within the IBC tank. You can also add a kind of IBC mixer. So just mixing up this additive prior to application is even simpler, more simple than mixing up a water-based coating. Next image, you see a typical thermal reclamation plant with the process chamber and the fluidized bed, and on the right-hand side, the addition of the thermally reclaimed sand. So I have now spent almost 60 minutes in talking, and I'm coming to the very end of my presentation, ladies and gentlemen. Thank you for all your patience and your interest. Let's just summarize what we have discussed. The thermal reclamation of alkaline phenolic sand can be controlled by certain sand parameters, which has been displayed and explained. We strongly recommend you to work with the maybe new way of measuring the sand quality by means of electrical conductivity. These measuring devices are broadly available. They are not very expensive and they are pretty reliable. This processing can be done easily. FOSECO is happy to support you in that respect, to make you familiar how to measure. And as important is, do not measure if you do any longer pH. pH does not give you any indication and any meaningful finding in order to control the sand. And once you get familiar with measuring the electrical conductivity of your sand, you will also be able to find a correlation with the true potassium and sodium levels in your sand. And in that context, also worthwhile to mention, in order to find this correlation, your binder supplier is able to support you. A good thermal additive can definitely support in reducing the residual alkaline components even to a higher degree. However, as said, it is not necessary at all to remove the entire alkaline content. Yeah, and finally, please forgive me that I'm restating this. As said, it is very, very important to pay much attention on the dust extraction process. Again, this can be controlled easily by sieve analysis and by measuring the fines, as a proper thermal reclamation of alkaline phenolic sand does require a proper thermal reclamation plant with controlled addition rates, with controlled fluidized bed temperature, by employment of a good thermal additive and a proper dust extraction. That's it. Thank you very much for your patience and for your interest. And this is now the end of my presentation.
Thank you, Dr. Alexander Schrey. That was very informative, and hopefully everybody will get benefit from this presentation, something quite special, quite interesting. While my colleagues are answering the poll questions, just few, it will take only a few minutes for them. We will ask them to put their questions on the chat box related with the presentation.
Okay.
While they are spending their time on asking, giving the answers to Paul, I want to ask you a few questions. One of them is about the angularity coefficient. Angularity coefficient of the either new sand or reclaimed sand. We know that reclaimed sand has got less angularity coefficient, not high. And that brings possibly benefit for the amount of binders need to be used.
Yes,
Yes.
You're fully right. You're fully right. This is usually an observation you can make during sand reclamation. And if we are talking, if we are just changing the topic slightly and going to mechanical reclamation of furan sand, we know that the subsequent low application of furan binder is possible as you are filling all the scratches and edges of the reclaimed sand, which has been where residual binder is allowed to stay and has not been removed by the thermal stage of the reclamation unit. Therefore, yes, what we do by means of a thermal reclamation, we unfortunately automatically, by removing the entire organic compound, we will end up with sand grains which are not that ideally shaped as they are shaped by means of just a purely mechanical reclamation, which is usually the case for furan bonded sands. So, in other words, yes, attrition process, mechanical reclamation followed by a thermal reclamation is about to alter the spherical phase, and this can be also measured. But as said before, it is very important to monitor that the abrasion during the mechanical treatment is not too high. What to do in that respect? We have to control both by minimum sieve analysis. We can also measure the gas permeability. The gas permeability will certainly increase, will get higher if you have a good spherical shape without an excess of fines, i.e. dust. And we have also control the D50 or medium grain size or AFS value, which should not change significantly due to the whatsoever reclamation process. And all that can be done or should be done by both the lab personnel and the lab within a foundry. However, when it comes to gas permeability check or even determination of the spherical shape, you may also rely on your binder supplier who is used to do these measurements. These are more advanced measurements, but I think they are absolutely essential, at least in the very beginning, if you start a process. Yeah.
Thank you. Thanks a lot. Arkadaşlar, soruları cevaplandırdığınız, memnuniyet anketine cevap verdiğinizi düşünüyorum hepinizin. Dolayısıyla soru cevap bölümüne geçtik. Soru cevap bölümünde sizin soruları alt tarafa yazmanızı bekliyorum. Sadece size zaman kazandırma amacıyla bir soru sordum. Sorduğum soru, reklamasyon sonrası kum yuvarlaklığında, kum köşelilik katsayısında bir değişim olup olmayacağıydı. Evet, beklendiği şekilde kum köşelilik katsayısında bir düşüş oluyor. Elbette kum yuvarlaklaşıyor. Yuvarlaklaştığı zaman daha az reçine ihtiyacı duyacağını, olması gerektiğini düşünüyorum. Onu sordum. Oysa meseleye farklı bir açıdan baktı. Bunun gaz geçirgenliğini doğrudan etkileyebileceğini, evet, yuvarlaklık arttıkça, köşelilik katsayısı düştükçe kum gaz geçirgenliği artacaktır. Bu sunumdan çıkartılacak pek çok sonuç var. Arzu edenlere FOSECO ile doğrudan, FOSECO Türkiye ile doğrudan temasa geçmeleri durumunda bu sunumun, kayda alınan bu sunumun hem İngilizce hem Türkçesini elde edebileceğinizi, ayrıca bunu TÜDOKSAT web sitesinde izleyebileceğinizi, YouTube kanalında izleyebileceğinizi söyleyelim. Evet, soruyu bekliyorum İsmail Bey. İsmail Bey bir soru sormak istiyormuş. Ben sizin sorunuzu da oradan kendisine sorabilirim. Buna eğer Uğur Bey'in mikrofonunu açarsak Uğur Bey de sorabilir. Doğru geliyor bu soru. FOSECO Türkiye reçine üretiyor mu diyor İsmail Al.
Derseniz
Evet.
siz, evet. Şöyle, Alexander, would you like to answer or myself? They're asking if FOSECO producing binder here in Turkey. If you mind, I can answer the question.
Yeah, please feel free to do so. Yeah, thanks.
Yeah, in Turkish way. Yeah, so herkese merhabalar. İsmim Uğur Gürol. Ben FOSECO Teknik Müdürü, Avrupa Teknik Müdürü olarak görev yapmaktayım. Şimdi güzel bir soru İsmail Bey'e teşekkür ederiz. Şöyle, biz evet FOSECO tüm Avrupa'da reçine üretimini yapıyor. Fakat işte uzak mesafeler veya işte maliyet sebepleriyle Türkiye'de çok fazla bu noktada bir iş oluşmamıştı. Yani biz açıkçası çok fazla buralara odaklanma zamanı bulamamıştık. Fakat yeni bir girişimimiz de artık Türkiye'de, evet, FOSECO olarak biz alkali fenolik reçinelerde bir üretime başlayacağız. Ve bu konuda tüm Türkiye'deki dökümhanelere gerekli görüldüğü şekilde işte istenilen onlara özel ürünlerle ilgili destek vermeye çalışacağız. Evet, güzel bir soru.
Mr. Schrey, are you able to read the questions or should I ask you?
Let me have a look, please.
From
Yes,
Also,
how is FOSECO going to differentiate themselves the existing resin suppliers, performance, lead times, and pricing?
yeah, okay. Well, the natural answer is that our performance is superior, the lead time are very short, and the pricing is very favorable to the customer. In fact, I'm sorry, just to take your question seriously. I think what we try to convey by means of this presentation is that we can clearly differentiate from others by means of the service element. The alkaline phenolic binders are not new at all. Alkaline phenolic binders are seen as commodities, but at the same time, being a resin supplier for many years, resin supplier also supplying alkaline phenolic binders all over the world, we see that in many many cases, there's a lack of understanding and a lack of proper application. And here it is down to FOSECO to step in and to support every individual foundry by giving the very best service. The very best service means that we do, for example, run constantly by visiting the customer, by understanding their needs. We do constantly monitor sand quality, for example, and give guidance, not just measuring sand quality once in a lifetime, but if necessary, join a customer when he is going to introduce, for example, a new mixer, a new thermal reclamation, or whatsoever, a new change, a significant change in process, just to help the customer individually by sharing our experience and expertise in order to obtain the very best outcome. We do believe there are certainly also differences in terms of quality. Just as an example and just as an indication, ester purity may differ from supplier to supplier. Ester purity is in case you employ poor quality, whatever it means you may end up with undesired problems in terms of odor evolution during core making. This is one element. But as said, a significant element where we are going to differentiate ourselves is the service element. So to give you support to make the very best of your binder and not just leave you with a situation where we see there's room to maneuver, there's room to improve. So if there's room to improve, and there's usually quite often room to improve, in order to check the service, in order to check the maintenance level of binder, mixing dosing units, of mixers, of reclamation, of dust extraction, and so on. I think by this we can differentiate ourselves, being on site with people who are experienced with this product and its application. And I think this is probably something which differs in many cases FOSECO from other suppliers.
Okay, thank you. Thank you for your quite satisfactory answer. While my colleagues are opening the microphone of Mr. Uğur Gürol, I will ask you, possibly you have got info, but Uğur will answer this question. Are you able to produce only alkali phenolic binders in Turkey or additional binders?
No, our intention, and this is something you will, not just may, but you will see in the next weeks and months, is that we will be able to offer the basically full set of organic, i.e. inorganic as well, but mainly organic binders, which are known in foundries and which are basically providing all certain requirements which are associated to these binders. So it's not just about alkaline phenolic binders, it's also in future also about other binder systems which are well known to make cores and molds for any kind of foundries, not just steel foundries, but also foundries for gray iron and cast iron and spherical iron.
Uğur Bey, bir ilaveniz var mı?
Yani şöyle, Alexander kısaca bilgilendirdi. Evet, ilk etapta biz alkali fenolik geçirlerine başlayacağız. Ondan sonra sıralamasıyla Furan, POCB olarak devam edecek burada. Tabii burada FOSECO sadece yeni üretmeye başlayan bir kuruluş değil. Yıllardır üretimini yaptığı birisi olarak ilk defa lokal olarak Türkiye'de üretmeye başlayacak. Sadece değişiklik olan bir şey bu. Sadece bunların reçete entegrasyonlarının o yapılması, oturması bir zaman alacağı için tek tek başlamaya karar verdik. Ve ilk olarak Alkali Fenolik reçinelerde, çelik dökümhanelerde varlığımızı göstermeye başlayacağız. Ondan sonrasında Furan, POCB diye bu şekilde sırayla gidecek. Bunların hepsi Türkiye'ye entegre edilecek. Güzel bir e, planlama ve girişim içerisindeyiz. Umarız faydalı olur diye düşünüyoruz. Bunların dışında hani bizim e, bu noktada en çok belirtmek istediğim noktalardan bir tanesi tabii birçok alanda ürünleri vesaire olan bir kuruluş, bir şirket olarak hani her zaman firmalara özel, yani firmaların kendilerine ait bir işte boyasıydı, bazen de iç besleyicisiydi. Bunları yapabildiğimiz gibi bu reçinede de çok önemsediğimiz bir yer aslında. Boya ile birlikte çok tam bir ikili oldukları için bu noktada biz daha çok müşterilerin ve işte Türkiye biliyorsunuz 7 tane bölgeden çok farklı mevsimlere sahip bir yer olduğu için her tarafta farklı reçineler kullanılmak zorunda kalabiliyor. Bunlara uygun, bunların en doğru reçetelerin en doğru müşterilerde seçilmesi için çalışmaları yürütüyoruz. Türkiye'de başladık. İşte çeşitli dökümhanelerde görüşmelerimize yavaş yavaş zaten e, daha da yaygınlaşmaya başlayacaktır diye düşünüyorum.
Teşekkür ederiz. Dr. Schrey, the activity in Turkey, World Founder Congress, is also supported by FOSECO Turkey. They are in between our sponsors. So we are going to ask you a support from another point of view. You should present some papers in the World Founder Congress in Turkey. We will force Uğur Bey and his team to do so, that this kind of studies should be presented also in the World Founder Congress in Turkey. It is the perfect time for sending abstracts.
Thank you very much for this very kind invitation, which will be certainly considered internally. Many thanks for this and for your interest. Thanks. Highly appreciate it.
Uğur Bey, ekibinizde neler yapıyorsunuz? Gönderecek misiniz makaleler Türkiye'den,
Tabii tabii.
kütüphanelerle birlikte?
Tabii ya şöyle biliyorsunuz TÜDOKSAT bizim için çok kıymetli. Bizim için değil, bütün sektör için çok kıymetli. Elimizden geldiğince her türlü noktada desteklemeye, ülkemizi temsil etmeye gayret gösteriyoruz. Bu noktada da biz global olarak çalışma yürütüyoruz. Alexander o yüzden biraz cevap verirken temkinli davranmak istedi tahmin ediyorum. Şu an globalde yürütülüyor. Gönderilecek yayınlarımız, makalelerimiz özel olarak hazırlanıyor. Şu an çalışmalar sürüyor. Birkaç hafta içerisinde globalde karar verilecek. Kimler hangi sunumları yapacak? Fakat lokal olarak bizlerin ayrıca müşterilerimizle de olacak. Burada çok değerli müşterilerimizle yaptığımız bazı çalışmalar var. Onlardan birkaçını biz lokal olarak ayrıca göndereceğiz. Globalden farklı olarak.
Okay, Mr. Schrey, Dr. Schrey, it seems that there is no more question, and we thank you once more a lot for this quite informative presentation, and hope to see you in the future at other activities of the founder industry.
Thank you very much, Seyfi. Thanks a lot. It was my pleasure to be here, and thanks to all listeners, to the audience. Looking forward to further activities in Turkey. Thanks a lot.
Uğur Bey, son sözlerimizi alalım, sonra oturumu sonlandıralım.
Teşekkür ediyoruz davetiniz için. Sunumdan sonra herhangi bir soru veya reçine ile ilgili teknik veya herhangi bir problem olmasında bizlere e-mail yoluyla ulaşabilirler. Biz en kısa sürede kendilerine herkese dönüş yapmaktan memnuniyet duyacağımızı belirtmek isterim. Teşekkür ediyorum davetiniz ve organizasyonunuz için.
Peki. Çok teşekkür ederiz arkadaşlar. Güzel, sağlıklı günlerde, yeni webinarlarda buluşmak üzere. Hoşça kalın.
Teşekkür ederiz. Have a nice day everybody.
Thank you. Goodbye.